Hey guys, BuildZoid here, and today I'll be speculating about the Ryzen 7000 series CPU deaths that have been in the news recently. And this is going to be very speculative. I don't have access to any information outside of what's publicly available on the internet, but I've had a lot of people message me about this, and yeah, I've seen the photos. I have thoughts about the photos. I don't have any facts about the photos, but yeah, like I'm making this video, so hopefully I stop getting messages about this. Anyway, so first off, the substrate bubbling up to me makes seeing the substrate bubbled up like that makes me think there's a short circuit on the V-core power rail. And the reason I say that is because in order to get the substrate to bubble up like that, you need a very high temperature, like north of 200 degrees Celsius, probably approaching 300 degrees Celsius, potentially higher than that. And in order to get to that kind of temperature, you're either depends where this heat is being generated, right? But if the heat is generated in the silicon, you're going to need a ton of it because the silicon is connected to the IHS through some solder, and the silicon already under normal operating conditions is producing, has a few hundred will have like 100 watts of power going into it across a few square millimeters. So you're going to need 100 a lot of you'll need a lot of power to generate a high enough temperature to damage the substrate like that. If the short circuit is in the silicon. Now, if the short circuit was in the substrate, you wouldn't need so much power because the substrate is a lot less thermally conductive than the silicon, at least as far as I know, or more like as far as I speculate, because I actually don't know what the thermal conductivity of silicon is. Or no, I do know I could look it up for silicon. I don't know how to look it up for the substrate. So silicon is relatively thermally conductive. I would hazard as a guess that the substrate is a lot less thermally conductive. So if you had a short circuit in the substrate, you wouldn't need a lot of power to get to a very high temperature and bubble the substrate like that. However, getting a short circuit in the substrate is very unlikely. The only two ways I can think of that would do that is a manufacturing defect from the factory combined with thermal cycling stress, or thermal cycling stress with mechanical damage, or thermal cycling stress in and of itself, maybe. And we CPUs have had substrates for years and years and years. I would dare say that manufacturers are pretty good at making reliable substrates these days, right? So I don't think there's a short circuit in the substrate. That doesn't make any sense, or at least. The thing is, once the substrate bubbles up like that, it actually might have more short circuits in it, because as the layers start delaminating, they might break through each other, crack, that kind of thing. Yeah, you might actually start having short circuits in the substrate. But I think the initial short circuit probably isn't in the substrate, it's probably in the silicon. And if it's in the silicon, well, the silicon is relatively thermally conductive, so we're going to need a ton of power to get a high enough temperature to, cause the substrate to bubble up like that. And admittedly, once you reach the high enough temperature that the solder starts to melt, you probably don't need that much power. Once the solder fails, and the solder fails at 160 C. So once the chip hits 160, the rest of the getting to 300 is probably much easier. But getting to that initial 160 degrees Celsius is going to be quite hard and require a lot of power, would be my theory. And if it requires a lot of power, then that power can only come from one place, which is the V-core power, V-core VRM, because VDD MISC on most motherboards is or at least on a lot of motherboards, is a 30 amp regulator. Straight up. It will not output more than 30 amps. That's probably not enough current to generate the heat necessary to damage the substrate. Then you have VDDIO MEM. VDDIO MEM on most motherboards is two crappy discrete MOSFETs, which is perfectly acceptable. You can use your crappy MOSFETs for your 10-watt power rail. That's just fine. That's sort of the whole point of having these low-end MOSFETs, is for low power applications like the VDDIO rail. Which also means that the VDDIO rail is completely incapable of supplying the amount of power that I think you would need to destroy the substrate like that. So that rules out VDD MISC and VDDIO. Then there's the SoC rail. Now the SoC rail is typically 2 power stages, rated for anything from 50 to 100 amps each. That could maybe supply enough current to damage the substrate like that, but I would assume that the VRM would probably shut down before you had enough power output to cause, like, to get to the temperature necessary to damage the substrate again. So I don't think SOC would be the source of the power that causes the damage damages the substrate like this. So that only leaves vCore, because the vCore power rail has to be able to power a 7950X. The 7950X has a 160 amp current limit, which means the overcurrent protection for the vCore VRM on most AM5 motherboards has to be like 200 amps or more, which means if you had a short circuit on the vCore power rail that pulls, say, 300 amps, most motherboards are probably perfectly happy to provide that 300 amps, and they will not complain about it. And then you'd have enough power to, heat the substrate to 300 degrees and getting it to bubble up like we see in a lot of the photos. At least that is a logical chain of events that makes sense to me. Completely speculative on my part. Again, I don't know how thermally conductive substrates are. I'd have to look up how thermally conductive silicon is. But yeah, I think in order to get the substrate to bubble up like that, you would need a lot of power, if that power is to be going into the silicon. Because the silicon is, again, it regularly runs at like 100 watts. That's regular, like expected operating conditions is like 100 watts of power going into the CCD, right? So if the CCD can run at acceptable temperatures while pulling 100 watts, in order to get it to like 300 degrees, admittedly, that 100 watts is usually spread across, a decent portion of the CCD. So if you had a localized short circuit inside the CCD somewhere, that would obviously reduce the amount of power necessary, but I still don't think it would be a little bit of power. It would still be a lot of power that you need. Sort of one thing that I think would be really interesting would be to take one of these dead CPUs and measure the resistance of the vCore power rail on it, and also maybe to turn it on and see how much current it pulls, because I would assume that the chip turns on and so the chip doesn't turn on because it's dead, but that brings up the other point. So most motherboard power sequencing works as follows. The motherboard turns on and then waits for the CPU to take over. So basically, if you have a dead CPU and you put it into a working motherboard, the motherboard will try to turn the CPU on, and if the CPU doesn't turn on, the motherboard will just sit there dumping power into the CPU indefinitely. That's just how that kind of works. And so, yeah, I think it would be really interesting to take one of these dead CPUs, probably even with whichever motherboard it ended up damaging, and then just seeing how much power that CPU pulls when you try to turn it on. Because I would assume it pulls a lot of power, because there's probably a short circuit on the vCore power rail. That would be a pretty good test to see, hey, is the vCore power rail shorted out? And yeah. But anyway, so so I think there's a short circuit on the vCore power rail, which causes the substrate to bubble up. Because any of the other power rails, I don't think they're able to provide enough power to cause this kind of damage. Now, why would there be a short circuit on the vCore power rail? Manufacturing defects are always an option, right? But rather unlikely. But yeah, you could have maybe a chip where the CCD is not perfectly aligned, and then with thermal cycling stress, the bumps that actually connect the silicon to the substrate, maybe those could short out, but I don't know, that seems kind of ridiculous. The other option is maybe a short circuit caused inside the silicon due to excessive overvoltage, which I would think would be and when I say excessive overvoltage, I'm thinking approaching 2 volts, not 1.5. 1.5 is the territory of you'd probably see electromigration related degradation over time. But if you wanted to cause an outright short circuit through the silicon, you would probably need to be at 2 volts or maybe higher. Or approaching 2 volts, basically, because you're talking about, we're not we're not talking about electromigration here. We're talking about oxide breakdown, like breaking down the insulating layers of the CPU, like inside the CPU. So you need a lot of voltage to do that. Now, if you reach that level of voltage, the CPU will die instantly. Okay, like there isn't like this isn't something that happens slowly over time. If you keep raising the voltage, basically once you reach a high enough voltage level, the chip just dies. Because once once the insulator starts breaking down due to excessive voltage, like it just gets worse and worse very, very quickly. So in basically the span of like a fraction of a millisecond, the CPU would go from functional to dead. And the reason I bring that up is because I saw one Reddit post where somebody had like some monitoring software record 2.6 volts, and if your monitoring software actually measured 2.6 volts, your CPU would be dead. I am very firm in that belief that like there is no way the CPU would survive being exposed to 2.6 volts long enough to actually record that voltage. Just absolutely no way. I could be wrong about that, but I think no way. Now, yeah, so then another option would be like mechanical stress or thermal cycling of the silicon. Like, yeah. So that's kind of it. Like, the damage to me looks like a short circuit. Why that short circuit like the substrate damage looks like the result of some kind of short circuit getting to a very high temperature. The only reasonable, like the only short circuit that could get to a high temperature that makes sense to me is a V-core short circuit. How that V-core short circuit develops, I don't really know. It might be like mechanical stress. It might be electrical stress. I have no idea. There's just no idea. I don't even, like, I can't think even of a good way to, like, test for this. I guess you could take a CPU and just run 2 volts into it, and if it ends up with a short circuit after that, well, I guess that's a decent indication that, yes, you can cause a short circuit with electrical stress, but that isn't a good indication that that's what caused the short circuit in the dead CPUs, right? Like, just because you can cause a failure one way doesn't necessarily mean there aren't other ways you can also cause the same failure, or at least a similar failure. And so, yeah, like that's kind of my speculation on that is like there's a short circuit on the V-core power rail. I don't know why there's a short circuit on the V-core power rail. Could be excessive voltage, could be mechanical stress, could be a manufacturing defect. There's a lot of different options. Now, why have I been only focusing on sort of the CPU side of this instead of the motherboards? Because I've seen at this point reports of this happening with ASRock boards, MSI boards, Asus boards, Gigabyte boards, and like the first reports were Asus boards, but then I think I saw like Gigabyte boards as well, and MSI boards and ASRock boards. So like evidently this is affecting all motherboard manufacturers, which means either this is like this could be tied to the actual manufacturing of the CPUs themselves. Also, initially, people thought it was like the X3D chips specifically, but I've seen also like a dead 7700X. Der Bauer, I think, has like a dead 7900X, which seems to have suffered the same failure mode. So, or like the same like end result failure where it has the bubbled up substrate and it doesn't work. But where was I going with this? Yeah, so it seems to basically affect like all CPUs on all motherboards. And so the options are like AGSA bug, or like a specification error, or the CPUs are coming out of the factory defective, right? Because if the CPUs are coming out of the factory defective, then they'll just die everywhere. It doesn't matter what board you use. If you get unlucky, your CPU just up and dies. If the motherboards have like, if the AGSA is defective, like if there's a bug in the AGSA, well, AMD provides the same AGSA to all the board vendors as far as I know. So if AMD puts a bug in the AGSA, everybody ends up with the same bug and everybody gets affected by the same problem. Now, potentially, AMD could have also put out some voltage guidelines to the motherboard manufacturers that weren't correct, but that doesn't really make any sense to me. So, yeah, but the fact that this seems to be happening just across, like, any CPU, any motherboard is like AGSA bug from AMD or like specification mistake from AMD because everybody's affected, or the CPUs are coming with like a manufacturing defect from the factory, and that then kills the CPU later down the line at random after like some amount of thermal cycling. Probably thermal cycling tends to be like the lazy excuse for any electronics related failure. Is just like, yeah, thermal, like if something is borderline, you thermal cycle it and eventually it dies, right? So that's kind of why like I'm bringing up thermal cycling, because that's sort of the catch-all for, oh, it died for reasons that we can't explain. Probably thermal cycling. Because it's like, what kills the BGA on a GPU? Thermal cycling. What breaks the, like, yeah, it's just kind of like, oh, anything breaks for any reason, you blame thermal cycling first, and then like other causes tend to be a little bit more like less likely. Now, I've seen a lot of speculation on the internet already about it being like too high SoC voltage or too high VDDIO. And I don't know why those would cause a short circuit on the vCore power rail. And I could be wrong. Maybe there isn't a short circuit on the vCore power rail, but from everything I've seen, like from the photos I've seen on the internet, is like, well, these have bubbled up substrates. That probably needs a lot of power. You're not getting a lot of power from the SoC rail, at least not compared to the vCore rail. The vCore rail, you could probably, well, you could you could definitely melt wires with the vCore rail. Yeah, definitely. But the SoC rail, I'm pretty sure you wouldn't be able to get enough power out of it to cause this kind of damage. So it doesn't really make a ton of sense to me that this would be like an issue with the SoC voltage. Because also, as far as I know, the SoC voltage doesn't go to the CCD, right? Like the CCD gets vCore and VDD MISC maybe, whereas the SoC gets SoC voltage and VDD MISC and VDD-IO, because VDD-IO is for the memory controller, SoC voltage is for, like, well, the SoC, and VDD MISC is for the Infinity Fabric, which is why the VDD MISC would probably go to both the CCDs and the SoC, or like the IO die. But the SoC voltage, I think, only goes to the IO die. Again, I might be wrong about that. I don't have any way to check. But yeah, so I don't, like, it doesn't make sense to me that SoC voltage would cause what looks like a short circuit on the vCore rail. That just, they don't seem related enough. I could be entirely wrong about that. But yeah, that just doesn't make a ton of sense to me. And I would not necessarily be too surprised if there was an actual like rare glitch in the AGSA that caused the CPU to randomly like get 2 volts of core voltage and then just die. Because that is a thing that has happened in the past, where like manufacturers would put out buggy firmware. Because there, like, a lot of people think that there's like some kind of crazy safety features all over everything, but there really aren't. Like most of the like safety features on a CPU assume that the motherboard is behaving as expected. There aren't like, you don't generally have like a voltage limiter that kicks in if the VRM goes insane. If the VRM goes in, like, the thing that makes sure the VRM doesn't output too much voltage is the VRM. So if the VRM goes nuts, well, there goes your safety system. Like, your safeties go with it, right? You don't have like a separate piece of circuitry that enforces a voltage limit from the VRM. I think it would be really cool if it did, because theoretically that would potentially protect from things like even like MOSFET failures. If you had a short, like a circuit that could just like force the voltage down, or at least cut the 12-volt power supply. But that's not a thing. Like, I've never seen that. Like, that best case scenario, you get a fuse on the input for MOSFET failures. And in terms of actually ensuring that the output voltage stays in spec, I mean, most voltage regulators will have like a hard duty cycle limit, but that's usually at like over 20%, right? So, and a 20%, like 20% duty cycle going from 12 volts to, well, convert like a buck converter with 12 volts coming in on a 20% duty cycle is going to output like 2.4 volts. That's enough to just destroy CPUs instantly. So yeah, no, there isn't anything like there's no circuit independent of the VRM that will prevent the VRM from outputting like 1 point whatever, like, well, 2 volts, right? If you tell if the VRM for some reason gets told to output 2 volts, it will output 2 volts. There's no safety against that, because the assumption in the design of the motherboard is that that just doesn't happen. That's just not going to do that. The firmware isn't going to tell the VRM to do something stupid, or the VRM isn't going to do something stupid for no reason, right? Like that's the other thing. Like there could be a glitch in the actual voltage controller, which I don't think is the case, just because so far it looks like, actually, it would be interesting to see if all of the motherboards with dead CPUs have the same voltage regulator. Like the actual controller is the same. I think, but I'm not sure about that. I don't know, like, I haven't, like, I didn't pay that much attention to this. So, yeah, also this video is getting way longer than it needs to. But, yeah, so basically my point is there isn't a hardware level voltage limit. There just isn't. That's not a thing. I've never seen it. That's just, nobody does that. The assumption is that the voltage regulator doesn't do stupid stuff. And the voltage regulator does have some, like, bare minimum safety features that are meant to prevent catastrophic failure, usually of the voltage regulator itself rather than whatever it's trying to power. So yeah, that's just like, if there's a bug in the BIOS or the firmware of the voltage controller or the AGSA, and the VRM gets told to output 2 volts, it'll output 2 volts, and your CPU will die, like, immediately. But like that, like hopefully, like, and I'd say if it is a software issue or like a firmware issue, the nice thing about that is that can be patched. If it's a hardware issue, that's way harder, right? That's like you're gonna have to like replace hardware instead of just roll out an update that fixes whatever glitch happens to be causing this. And again, it could also be that there's just like a batch of bad substrates or something with these CPUs. Like, you know, maybe some of these CPUs got soldered a bit wrong in the assembly process and somehow snuck past QA. I don't, like, I don't know. But like, the thing that, like, I don't think it's the SoC voltage. Like, I don't see a reason that 1.4 volts of SoC could cause a short circuit on the vCore power rail. Yeah, mind you, I do have a dead 7950X, right? And my dead 7950X has a dead memory controller, like properly dead memory controller. On Asus boards, it shows 00 post code, but on Gigabyte boards, it shows memory initialization errors. And I've checked the resistance of the vCore power rail on that CPU, and it's fine. The vCore power rail is completely fine. Also, the substrate is completely flat. And I did run that CPU without a heatsink for a few moments. And I didn't really notice it pulling like excessive amounts of power. So like that CPU, if there was a CPU that died due to excessive SoC voltage, like my 7950X is probably the #1 candidate for that. And it doesn't have any like substrate deformation, vCore short circuit, anything like that. I didn't check if there was a short circuit on the SoC rail, but yeah. That's the main reason I didn't do that is I don't remember off the top of my head where to check the SoC resistance. I guess I could just put it into a motherboard and check the resistance that way. It's kind of the easiest way to do it. Put CPU into motherboard, check the resistance. Yeah, so that's my current like speculation on this is like, to me this really looks like either a manufacturing defect in the CPUs or a like VRM glitch caused either by incorrect VRM programming or incorrect AGSA programming. Because if the VRM gets told to output 2 volts, it will output 2 volts. There's nothing stopping it from doing that. It shouldn't get told to do that ever. But like, yeah. And the thing is, like, I've seen in the past motherboard, like, there was a series of motherboards that had a glitch that would randomly make them boot at, like, 1.8 volts vcore. Even if you, like, cleared the CMOS. It wasn't like, oh, you were overclocking or something. No, you cleared the CMOS, and you'd restart the system, and sometimes the board would just boot up at, like, 1.8 volts vcore. And that was, like, a bug on some motherboards many years ago. And then also there was a BIOS update from Gigabyte on X370, where they set the SoC voltage to, like, 1.55 volts. Or one, yeah, so it's just something absolutely insane. And that very quickly degrades the SoC on the CPU. And so, like, basically, if the BIOS tells the VRM to do something stupid, the VRM is going to do it, right? Like, there's nothing to stop that. The only assumption is that the BIOS doesn't tell the VRM to do anything stupid, and the VRM doesn't do stupid things. But yeah, so that seems to me like it would probably be the likeliest cause, is if there was just a glitch in the AGSA that sets the voltage insanely high for no reason, and it blows up the CPU. Other than that, it's like a manufacturing defect. Those are the only two things that would make sense to me, because it, like, happens on every motherboard. And again, like, it might only make sense. Like, again, I should point out, like, I am speculating here, right? Like, I don't know that there's a bug in the AGSA. I don't know that there's a manufacturing defect. But I can't, like, within my limited understanding of motherboards, CPUs, and electronics, I don't know how you get the substrate to bubble up with anything other than a short circuit on vCore, and I don't know how you're causing a short circuit on vCore with anything other than the vCore power rail itself or a manufacturing defect, right? So yeah, that's it. I'll end the video here. It went way longer than I wanted it to, but at least it's done now. So yeah, again, this is highly speculative. I'm probably completely wrong about everything I said here. Okay, that's not true. I'm relatively confident I understand how a motherboard's power sequencing works, considering, you know, how many times I've bought dead motherboards and they still turn on, even if they can't start the CPU. Actually, you can get motherboards to turn on without the CPU in the socket. You just, depends on the motherboard, though. Some motherboards have, like, a CPU presence detection circuit. In which case, that circuit literally, it doesn't ask, like, it doesn't check if the CPU actually works. It just detects that there's a CPU physically in the socket, usually by shorting something to ground. So, yeah, you could potentially, like, fake that with just jumping the correct pin to ground, and then, bam, motherboard thinks there's a CPU. But, yeah, so I'm pretty confident about how, like, motherboards power on. But a lot of the other stuff, yeah, highly speculative. So, yeah, I don't like. Basically, the informational value of this video is, like, 0. There. I hope that's enough of a disclaimer. Anyway, thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. And if you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the HOC Teespring store, and I've got a Bandcamp. And yeah, that's it for the video. So thanks for watching, and goodbye.